Hello everyone, today we are going to do our first Rust video tutorial and we're going to talk about trait objects, also called dynamic types. And in the same time we are going to answer a question or to explain more a question that I've seen in a tweet. I cannot find the tweet back, but it's what about how to extract dynamic type that we put in a enum. So I'll explain that. But more of that, it will be how to implement a real dynamic type and see how we can use it on a concrete example. So basically, what we are going to code is not something practical, something that we can use in real life. It's more about how to manipulate the trait objects. And we also see a lot of mutable references. And it's going to be interesting to analyze what we can do and what we cannot do. So we have a whatever enum where we can put trait objects, but trait objects are manipulated through boxes or reference. And we will call our trait object scalar. So let's define a trait object. An empty one for now. And our goal is to extract the value that will be here in a box. So we have a function extract. So that was the question on the tweet. And we pass the enum. And the interesting point is that we want to return the reference on a scalar. So the reference, because it's a reference, we need a lifetime, as we've seen on a previous tutorial. And because we want to return a trait, we have to use dynamic. So what is it exactly? It's in our enum, we can't put anything that implements scalar. We can think first that it's the same as generic, but it's not. Because when you define a generic for t parameter, for example, and when you set up your t as a i32, all the inner object here will be forced to use a i32. But in our case, we don't force anything. We will be able to use any scalar in the same list, for example, or we can mix things together. We have no constraint about which scalar we are going to use. We'll see that in our last example. But that's the main difference. So for now, we just want to extract things. So and the function will return the scalar itself. So because we have a ref to box, now we have to just find what's inside the box. So there is there are different ways to do this. That was a question on a tweet. So the first obvious way to do it is to say, okay, let's return as dot as a ref. Let's put it in a variable to make it clear. Okay, when you do as ref, the implementation is clear. It takes a reference to self and return a reference to T. So in our case, it's gonna return a reference to Scholar, which is here. And it is exactly what we want. So that was a question on a tweet. But there is other ways to do this. This one is the best way. We can also, let's do it step by step. If we take something like S, we get the box, okay? And then we want to deref the box. So to deref the box, we can do deref like that. You see, it works. We get a dynamic Scholar back, a ref to dynamic Scholar. But instead of the deref, we can do something like that. It's not exactly the same, but that actually it's something. We should read it like that. Okay, so the same. But a cleaner way is to use as ref. So, little quick test. Okay, before testing anything, we cannot create anything for now because we didn't implement Scholar for any type. So we can implement it quickly for integer, for example, I32, for example. And then extract the value from the union. Print line. We know that when we want to print something like that, we need the debug. On the Scholar. So probably Scholar must force the debug implementation. Okay. So nothing very complicated. What we just did is that we implemented the trait for i32. So now it recognizes our type here. It's allowed to place something like that here because we implemented that. And in our enum, we can extract the value in that, which is a reference to a scalar. And this one can be printed because it implements debug. But now we are going to do something more subtle. We are going to implement a feature in our trait. Sorry. Let's say we want to increment the value of our scalar. The scalar would be, for example, i32, it could be a vector, for example. And a vector, incrementing a vector will be to add 1 to each, to every element of the vector. It's a common feature, let's say. And then we are going to return, we don't have to return anything, but for educational purpose, we will return something. When you want to define a trait object, you have a lot of constraints on what you can define as a method. And that's the real trick. You cannot use anything you want as a parameter here. It makes a trait object a bit difficult to use. But for now, just let's implement this one. So in this case, self, it's i32, and we want to change it. So, okay, because we want to change it, we need a mutable reference. We want to change the inside the object. And then we want to return a box on a scalar. On the scalar that is in the that has been incremented. Okay, so let's try this. How do we try this? Okay, we could try it right away, or we can try it in another function, for example. Let's say we want to extract and increment as well. Then we have a scalar here, and we want to increment it. Okay. So to do it, okay, it doesn't work. It makes sense because this one is not mutable. So to be able to mutate the content of the whatever here, we need to have something mutable here. We need to have a mutable reference here. And now that we have a mutable reference, we cannot simply do as reference. We have to do as mutable. Here we go. So when we change that, it will change the content of the enum. You will not only change the value of this variable, it will also change the value of this, because those two values are linked, and they are deeply linked. Even the return, even what you return here is linked to the enum. Okay, so then we can try to test our test 2. So this one must be mutable, and we need a mutable reference. Okay, 41. So we add one more. Okay, what about printing E? Equal. To do that, whatever, I must implement debug. So let's do that. Okay, so we see that we extract the right value, but inside the enum, the value has changed also. But now we could implement the Scala for a little more complex type. I32, vector of I32. Okay, so in our case, in this case, the self reference, it's a vector. It's a reference, a mutable reference to a vector. And what we want to do is that we want to change every value of our vector. But we know it's mutable, so we can do iteration, mute, and for each element. And then we can have our closure on each element. Let's say item So let's save it for later. We'll see what we put here. It can be interesting. But in our case, so it should be simple. It should be like we want to change the value. So, and we want to add one for each of them. So it should be something like that. Because it's a mutable I32, if I take the reference, I can change it. But this is the inner element of the array, of the vector. And in here, we want to return something. But if we do that, we could say, okay, that's cool. We have a self here, and we want to return. So self is a scalar itself, but we cannot move it. It makes sense because we just have a reference to it. We don't own it. So we don't have a choice. Because we want to return the scalar itself, we have to clone it at this point. You can say, yeah, but why do we have the right to clone it? In our case, we can do it because the scalar, it's a vector i32. So this clone, it's actually the clone method of the vector i32. This is why it works. If you wanted to return a reference to it would be possible to return a reference of the inner stuff, but it won't be actually a reference into self itself. In this case, it will be a lifetime here. But that is not our goal for now. Oh, the tricky thing that you cannot do that actually for trait objects. That's a big limitation. Yeah, I mean, if you have a signature like that with a function inc whatever, and you want to return something with self here, well, you cannot, even if it's a reference here. It will just kick you out. So that's a shame, because even if you want to do that with the right lifetime here, you cannot. And it's a huge constraint on trait objects, because it prevents you to do, you know, dot, because you cannot return itself. So this is why we do that. We do it in a box. Even if you do it in a box, I mean, even if here I put a reference to self, it's gonna kick me out. It doesn't work. A trait object doesn't accept any reference to itself. So probably for complicated reasons. But there are a lot of debates about that on a chat, and probably Rust will evolve on this point later. Okay, so we have our feature, which is implemented for vector i32. So let's do a last test. And instead of a box on a box on integer, we do a box on a list of integer. We inc and extract. Okay, let's test it quickly. Yeah, you see, it worked right away. So it's kind of powerful because we haven't changed anything here. All those lines are the same. What we did, we only did that. Can do something a little more ambitious and have, let's say, vector v be a vector. We're gonna mix things together. So for example, we're gonna put something mutable on an integer here. And then use this one on a vector. And here we can E1, okay, reference, mutable reference on E1, mutable reference on E2, And let's say the vector is mutable as well. And we can, for our first test, can try to extract the value on the first element, second element, or whatever. To make things clear, we can do that like that. Item. Just to display the type of what we want to manipulate. So we have a mutable reference here. Yes. When we do that, we are going to move this, and it cannot do that. So what we better do is to use exactly the value here. Here we go. In Rust, anytime you extract a variable from a parameter, you extract a parameter to make it as a variable. It's not a natural operation, because when you do equal, you do things. So here you pass exactly what is expected, because it's gonna difference the vector and extract the element, and the element it's a mutable reference to the element. So it's why it's work. So exactly it matches exactly that. The reference, mutable reference to whatever. And we got a value here. So we got 2, 3, 4, which has been increased because we had 1, 2, 3. So the mutation of the vector worked very well. So because we are here, we can also do something like for, let's say, item in our vector. And we could just repeat the line here. So we want to process all the elements. And we display that. Let's try that. Here we go. So we increased the first one, which is 40 to 41, because it was 40 first. Yeah. Then we increase this one. So it would be clearer if I just comment it out. Yes, you have the two items, 41 and the vector. So it was 40, now it's 41, and now it's 2, 3, 4 instead of 1, 2, 3. So we have the two items that have been incremented. So it works exactly the same way with the same routine, not a routine that was copied. Interesting thing is that here, when you do star item, we just get the immutable enum, a ref to a mutable enum, because of this. So If we don't do that, it's not going to work. Why is that? Because you cannot go through, you have some kind of transitivity in mutation. So you cannot go through the vector v if it's not mutable to ask for a mutable reference in that inside. So it won't work. So you have to have mutable to access the mutable element here, more or less. So it's powerful, and this is gonna be a feature, and it's already a feature used in Rust a lot, and it will probably evolve again to have even more power, because today we have a lot of constraints. So keep in mind that every time you want to use something, don't be afraid by the dynamic keyword. It's exactly as if you did that, but not now. It's deprecated. So to make it clear, they decided to add a keyword. The only thing you have to keep in mind that you have a constraint on the definition of the method here. So because you cannot use self here and self here as well as an input parameter, cannot, for example, define an entry parameter like that, for example. So you can probably put, you can put it in a box and use a dynamic scalar like that. The problem of that is that you have your new scalar, okay? But the problem of that is that for specific implementation, for example, your scalar it's a vector, but in your routine, your Ink routine, when you want to implement the code, you probably want to manipulate that as a vector, but you can't because you have basically. No, it's not totally true. You probably can do that because you can return. It's complicated to cast that into your original type. It's doable, but it's complicated. You can do it with any box scalar. I don't remember the name exactly, but we have something that allows you to do a cast and to retrieve your. Probably it manipulates pointer behind the scene. But anyway, you will not able to return it correctly. So a lot of investigation to do then. But it's not very flexible. We would like to use the self, but at least something like eSelf, like that. Okay, so I hope you enjoyed the coding session. See you next time.